In this chapter you will learn how you can easily implement your machinery and process routines using the graphical programming language Graph. Many applications from manufacturing and process technology can be divided up into sequential routines and displayed accordingly. These sequences are often described with flowcharts. With Graph, these flowcharts can be implemented one-to-one in sequencers. In a sequencer, you initially divide up the program into individual steps. One step can in turn contain various actions. The current step remains active until the corresponding step-enabling condition, also referred to as transition, is fulfilled. Afterwards, the next sequence step is processed. In the event of a fault, there are interlocks and supervisions that monitor the active step and automatically create an alarm. The Graph sequence chain can even be displayed in the HMI. For simple routines, the steps are processed in linear sequence. For more sophisticated routines, they can be displayed in several parallel routine branches. With alternative branches, depending upon a condition, one single of several possible routine branches can be sequenced. Simultaneous branches enable parallel processing of different routines at the same time. How does that look in the TIA portal? In our example, 2 lifting units are to be controlled. To do so, first create a Graph function block in your project. You program the sequencers with a Graph editor. The program window offers a function bar, navigation and an operating range. Via the function bar, you can switch between the views of the operating range, for example. The navigation offers fast access to all components of a sequencer, and in the operating range, you program the individual components of your operating range in the relevant view. In sequence view, the first step, the so-called initial step, has already been created. Based on the flowchart, you establish the structure of your sequence chain here. You add the program elements into the function block by clicking on the elements in the favorites bar, for example, steps, transitions, alternative branches, or jumps. As long as a step has no actions, it is labeled. For better legibility, give own names to the steps and transitions. In single-step view, you determine the actions to be performed while the step is being processed. In our example, the first lift unit is to move time delay to the top. Under transition, you program the enabling conditions for the following step. In the example here, the condition is fulfilled as soon as the lift unit has reached the top. You can uncover faults via interlocks and supervisions. Under supervisions, you observe the step duration, for example. The corresponding alarm text is already integrated into Graph and does not need to be programmed. With an interlock, you monitor whether an action can be executed, that is, whether the door on an opening to the lift unit is closed. The individual actions in a step can be controlled depending upon one interlock. In both cases, an alarm text can be generated and displayed. Under permanent pre- and post instructions, you can additionally create the programming code that is to be processed in each cycle. This enables you to intervene in the active sequencer where required. Under Alarms, you see the configuration of your supervision as it was performed in the central supervision settings. Also in Sequence View, you can display actions and transitions and obtain an overview of the entire sequencer. The graph FB must now be called up, for example in the cyclically processed organization block OB1. To do so, you need to connect the necessary input and output parameters accordingly on the function block interface. For tests or during commissioning, you subsequently load the project into the controller. By initiating the monitoring function, you can now monitor the sequencer online, both in the navigation tree and in the operating range. If there are faults in the routine, the step affected is marked in red. This greatly facilitates troubleshooting. The monitoring of an active sequence can be displayed on an HMI device. This enables troubleshooting even without a programming device. With a programming in Graph, you can implement the routine in your plant directly one-to-one in sequences. Graphical programming always provides you with a good overview, and thus you can easily and quickly locate faults on the HMI.